All right, folks. Today's agenda is on learning the deep neural networks and fine tuning. This is supposed to be our agenda, and I'll try to speak on fine tuning side of things. And Pawan can help to fill in the gaps in fine tuning, and he will also help us to know about the deep neural networks. Okay, that is what it is about today.
Yes.
Yeah. So I'll start with uh, the requirement. What is fine tuning first of all, right? So there are different ways you can create a large language model, right? One is if we use a model, a very small model from scratch and build on top of it, right? Like building a model of scratch is one thing to do. Like OpenAI has built the GPT model, that is, they have built it from scratch and they have built like a model with like trillions of parameters, right? That is one way of doing it, and that takes like millions of dollars, right? And OpenAI has supposedly spent roughly around 100 plus $1 million to train their GPT model, right? And supposedly, China's DeepSeek labs, DeepSeek AI's DeepSeek V1, R1 or V3, these models, right? Like R1, if I talk about, this is also a huge model. I forgot about the number of parameters it has, but it is also, I think, in very high in billions or close to trillions or something. And that model has taken roughly around like $5 million to train. So they have done enough in 5% of the amount which OpenAI has done. And like Bloomberg is also famous for coming up with their own Bloomberg GPT, which they have built from scratch. Like Bloomberg is a company which holds a lot of financial data, and they have used all that data to build a model from scratch called Bloomberg GPT. Just to, just a normal what you say, just to give a context on things, right? So this is how we build model from scratch. It is only possible for huge companies, right? Like we need funding to build that model. It takes millions of dollars and takes so much time. Now, second thing is to actually use an existing model as your base model and build your business objective specific intelligence on top of it. And as you may obviously will guess that this will be comparatively cheaper than building the model from scratch, and it will be less time consuming as well. Although it takes time, but obviously not as much as it takes to build a model from scratch. So that is the idea of fine tuning, okay, where you make use of the property of the models called as transfer learning, right? And by that, I mean is you use a base model, you use its learnings, and you add your learnings on top of it, and you uh, build a model which to achieve your specific business objective. That is all what fine tuning is about, right? And uh, so if you want to get uh, better responses, better results from a model, there are different ways to do it. Like one is inference. Sorry, two ways to do it only. One is inference, and the other is fine tuning. And at the inference
Inference,
way, inference is
I
one
didn't
way.
get that.
Okay, so there are two way to get good results from a model. Okay, one is your inference, and other is your fine tuning. By inference, I mean like you can use techniques like multi-shot prompting. You can use techniques like RAG. You can use techniques like tools or function calling. You can use techniques like MCP, which helps us to feed in more context to the user's query and then gives you the better results at the inference time. You're not kind of affecting the weights of the model by anyhow in this technique. By weights, I mean parameters. right? You are just using the model as a black box, as a frozen box only, and you are prompting it in such a way with adding so much context to it so that you get very nicely detailed, accurate, right results for your query. So that is inference level improving the responses. Other is fine
Yeah,
tuning.
that's kind of like a alternative to fine tuning.
Yeah.
That's like when you don't want to do any fine tuning, you use the plain LLM model, but you want the additional, I mean, results for your private data or additional capabilities than what LLM is currently trained for. We'll do those things. Also, I mean, prompt tuning is there, right? So that is you give the things in the prompt only and get the answers, relevant answers
Hmm.
from the LLM.
Hmm. 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 Right. Right. Inference time, we have spoken about like RAG in last few weeks, and now we'll talk about fine tuning side of things. So yeah, fine tuning actually depends. Actually, has a concept called as generalization. And by that I mean is you train the model, you pick up a base model, like suppose I pick Meta's Llama 3.2 3 billion parameter 16-bit model, and I use that as a base, and then I have some specific business objective to achieve with the model, and I'll have that business specific data which I'll use to achieve my business objective with the model. So what I'll do is I'll use that business data, I'll curate it, I'll pre-process it, and then I'll use it to train the model with it so that it becomes accustomed to my business specific objective and helps to kind of serve the purpose for that business objective. That is what generalization is about. It is about like when you train your base model on a data, your model, your large language model, your deep neural network, it tries to figure out the patterns in your data, the patterns between your inputs and outputs, okay, and tries to, understand those patterns. And when you kind of query that model, it will help to predict the output which becomes consistent with your training, right? That is the idea of generalization, right? It is about,
I I actually did not get this generalization.
okay.
Um,
And let me
I,
explain it in a different way then. So what you do in fine tuning is you take the data and you train your model on a very high level, okay. But what you do with the data, you don't use the whole data as such with a model. You pick up the training data, you pick up the data, then you break it into three pools. One is your training data, second is your validation data, then you have your test data. You have three pools of data now. Suppose
yeah,
suppose you have like 20,000 uh, training examples, okay. Okay, in your data set, which you will use for training the model. Then you divide that 20,000 into, say, you keep 15,000 into your training data set. You keep 2.5K into your validation data set. You keep another 2.5K into your test data set, right? These are the
yeah.
you hold the data. You don't train them. You will not train the model on the whole 20K data training examples, but you train it on only 15K. I'll tell you why we need that. So what you do is you take the 15K data points, they're your training examples, and you train your model with that data. And when you do that training right, your deep neural network tries to understand the underlying patterns between the inputs and the outputs. Like, is there a pattern between the input and the output? For example, I'll give you an example to get better context, better clarity on these things. Suppose you are trying to fine tune a model to achieve an objective
Oh,
where you want to predict the price of an item, okay, based upon its description. So you have Amazon products. Okay. You have the description of the items on an Amazon product. Like you want to buy a laptop on Amazon, you have the description of the laptop on Amazon. So picking up the description and feeding it to your model and asking it to predict your price. Okay. That is what suppose you're trying to achieve. So you will train the
Okay.
model on that data, on that description of the laptop, okay, so that your model is able to understand, and you train it not only one piece of laptop data. You'll train it on like 15,000 such data points, like 15,000 laptop data points, separate descriptions and all. You train the model on that, and your model, your deep neural network, it tries to figure out the patterns, okay, like if suppose I'll just give you some ideas. Like suppose if this if a laptop has GPU VRAM built in, it will be more expensive. If description length is huge, maybe that is more expensive. If the laptop is heavy, maybe that is more expensive. Or maybe if laptop is light, then it may be more expensive. If screen is big, then it may be more expensive. So you don't have to specify all these things because you're not explicitly programming the model. You're doing the machine learning. You're training the deep neural network. So it will automatically figure out the patterns between the details of the product that you have given to the model and the price. And that is your 15K training data points on which you train the model on. And understanding those patterns to predict the price, okay, is what the generalization is all about. Then
I
comes
got it. I got it. I thought you are some. I thought that there is something you are saying generalization with very specific to fine tuning. I thought. Okay. This is generalization. I mean, it is something related to usual training itself,
yeah,
right? There is
yeah,
underfitting, there is overfitting, and
yeah,
there is generalization.
yeah.
Got it. Yeah, got it.
Yeah, it is if you try to build a model from scratch as well, you will have to, the same pattern will follow, the same generalization concept will follow. That is the core of your training. That is the core of your fine tuning as well.
Yeah, I just want to ask Pinakini, are you getting this actually? Because I don't know if Pinakini is there.
Yeah, yeah, yeah.
Because I feel that we are directly jumped into something. Okay, I mean that's how we planned this session also. So even I was like, okay, what is this? Where is this
Fine-tuning
coming
part,
from?
I got it. Generalization is something that I understood now. Uh,
Okay, so
so
you know.
generalization also is looks like it's also a type of a fine-tuning. Is that so?
No, no, it's not type of fine tuning. So before you say generalization, I think you should understand what is underfitting and overfitting. If you understand that, then it's very easy to understand the generalization.
Okay, okay.
Then
What
let
is
me
it?
do one thing
Underfitting?
here. Pinaki, let me do one thing here. So what I'll do is I'll explain the remaining data points also. Then you will know what I'm trying to say. That will help to clear that. One way is that way. Let me try to explain that way. Okay.
No, no. What Pinakini, I think you should ask questions, okay? Because we are not very structured here.
Yeah.
So,
Okay.
Hey, hi Dhananjay. Thanks for joining, man.
hey, Dhananjay, thanks for joining.
Yeah,
And yeah, hopefully, I don't
Even
know
I
whether
might have missed like few sessions in the beginning, so I am thinking that probably you would have covered some overview
no,
there,
No,
that's
and
okay.
then,
nothing like that.
No,
Mhm.
no, no. The idea here is not to like what do you say? Not to. We are not structured. Okay. So you come
Mhm.
in. If you don't understand, you ask question. We
Okay.
have to repeat. We will repeat. It's okay for us. I mean, it
Mhm.
will make us also understand the ideas better, right? I mean,
Yeah.
understand the concept better. So you ask question. If you don't understand, we'll try to explain. Later you can go back and check also, but whatever we can tell, we will tell. And also, like, it's not that we have to cover this part today and all. What we have to, we will try to bring everyone into the same level or page. Okay.
Okay.
That is the whole
Mhm.
point. Yeah. Breaking
Yeah,
up.
thanks for joining, Dhananjay. This may not be very useful for you, but we are expecting some knowledge from you also, Dhananjay. So feel free to anytime drop off if you have work or anything, Dhananjay, and
yeah. Only
feel
this
free
week and
to.
next week I was in one production call, but from after next weeks I will continue join. But I will try to join as long as possible today. Huh?
And whenever we discuss, feel free to take up a
For
topic
sure.
or explain. Okay. And Vinal and Pinakini, they're my colleagues from Oracle.
Okay.
Pinakini is still working in Oracle. Vinal got recently laid off. There are other peoples also who are working and laid off also from Oracle. Okay. Yeah.
Okay, enough
Okay,
about
Vinal.
layoffs. Okay. I was supposed to push this video to public. Okay, others can see, but I haven't disclosed my layoff news
Oh, no,
outside.
man. No, no, don't do that. Make it private at least.
Okay, I have to make this one private for sure. No, I cannot.
No,
Okay.
make everything private. It's okay.
All right, all right.
Okay, you can
Okay.
continue.
Yeah, so talking about the training or during the fine tuning, right? So what we do is we divide the whole data, as I told, into three different pools. First is your training data set, then your validation data set, and then your test data set. Suppose you have 20K training examples which you have collected for fine tuning your model, for training your model. Okay. So what you do is we'll take that 20K examples, we'll break that into three pools. Okay. The first pool will be of 15K, for example, and you put that into the training data. Okay. 2.5K into validation and 2.5K into test. Now you pick the first pool, your training pool, and you fine tune your model on the training pool. Okay. Fine. And once your training is completed for the model, if you pick any training example from the same training pool of 15K, the model will be able to predict it accurately because it has learned about it. It has seen the data before in the training. So it is able to predict about it. But what if the point is not that? The point is you have to test it on the data which it has not seen during training. And that will come in the validation side of things. Okay. So second comes the validation data set. You use that data set and then you hit your model with that data set. And you check if the model is able to predict rightly at that time or not, or closely to your expected value or not, right? And then you figure out if the model has, if model is able to predict a price which is close to the actual price of the product, okay, in the validation, then that means your model has generalized well. It has understood the patterns between the inputs and outputs well. But suppose it is not able to do that, it is predicting the price anywhere away from the actual price of the product, then that means it has not generalized well. It needs more training. And then what we do is, if the model is giving results away from the actual values, then you figure out the loss. You do the loss calculation, like how far is the model from the actual price. And accordingly, you tweak the parameters in such a way that your loss becomes less and your price becomes closer to the actual price. Your model's prediction becomes closer to the actual price of the product. Okay. And once you keep on iterating between the training and validation again and again, you keep on training, you keep on validating. And finally, when you see that the validation results are passing, right? Then at the end, when you're at the final iteration, you have done your final iteration of the model, then you run it on the test training data. That is the unseen data again for the model. It has not seen it at all during the training and validation. And then you check again. And then you see if the model is able to predict the data, if the actual price rightly or not. Right? Uh, yeah. That is what the generalization is. When the model, depending upon its training data, it figures out the patterns between the input and output, and it captures those patterns. The deep neural network captures those patterns. The model captures those patterns. And when you give it an unseen data, it is able to predict the price really well. Not anything out of the sky. Okay. That is what generalization is all about. And when you speak about overfitting, that means I'll tell you about that. So when you train the model, oh, sharing something. Okay. So if you train the model too much, okay, what happens is your model, instead of generalizing about the things, it starts trying to remember those things. Starts trying to memorize, cram those things. Okay. So if you give the data that it already knows, it will give you the exact price. But if you give it an unseen data, and it say anything out of the box. Okay, so that means the model has overfitted. It has landed into the situation called as overfitting. Okay, and we need to take the model out of the overfitting and back to the generalization. That is the whole point of fine tuning. Am I good or is it ambiguous till now?
Yeah, Vinal, it's good. I think I will have to note some points and try to
Yeah.
check more. Yeah.
All right. All right. Cool. So, yeah. Next
Okay,
come.
I was on mute.
Yeah, Paul.
Yeah, it was good, Vinal. But only thing is that what I felt is that visualization will add a bit more into that.
Yeah.
So maybe I'll cover a little bit.
Yes.
Okay,
Please.
underfitting and overfitting. So let's say you have these kind of data sets. Okay, we are trying to classify the blue points and the yellow points here or orange points here. Okay, so what happens is that you train these data sets into a model, machine learning model, traditional or even the LLM. Okay, if you don't have the enough data set, okay, then there is a chance that it underfits. Okay, you train less or with the lesser data sets, it underfits. Okay, it is not able to properly identify all the points because you haven't trained it with the full available data set, or you have the limited data set, or your training was not enough. Okay. Then there is another case where you train too much. You have the data set, or you have the very good data set, enough data set. Okay. With that data set, you have trained again and again, again and again, again and again. So the model fits exactly into that data sets, whatever your training data set is there, right? The model will try to fit to those particular data sets which you are training because you are training again and again. Okay. So if you see here, right, that for
So that
every
means
pass,
it will not perform well when we ask ask
yes,
new questions or new data.
Exactly.
It will not be able to.
exactly. So in this case,
Okay.
suppose
Mm-hmm.
there comes an say blue dot here. Okay, here if you new data, okay, you are asking for the new data, these are all training data. Let's assume we put a blue dot here, so it will not be able to, it will say that it is a orange one. Okay, whatever comes within this orange side here, this narrow gap, right? If something blue comes here, it will say it is not blue, it is orange. So here also there is a chance that orange dot can come here, orange data, whatever data is trained for. So the orange can come here, fall here also, right? But it will say it is blue because it falls within this narrow region.
Overfitting is like a cramming
Okay.
kid, okay? It is a guy, it is a parrot, okay? Whatever it has trained on, it will say exactly those things. Whatever
Exactly that,
comes
yeah.
new,
Yeah.
it will be like, what? Anything like it will say. That is what cramming
Yeah.
kid,
Mm-hmm.
parrot is what overfitting is.
Okay.
Yeah, so this is kind of a generalization. This is optimal, wherein you
Mm-hmm.
put uh, like try to not deviate too much or into the overfitting side. Okay, not like you train too much. There is like when you train, right? If your this loss is kind of not what is it? Loss is less, or your weights are not changing by certain amount, like not changing too much. Then
Learning
you should
rate.
stop your training. Not learning rate. The weights are not changing, right? Like when you train, when you hit an optimal solution, your loss will be less after this. Okay,
Yes.
and your learning, what happens is that your the delta of the weights will be minimal. After that you don't need to train actually, so you
Yeah.
need to stop there.
Yeah.
And but there are other ways also, like regularization. There are other ways to avoid the overfitting, but
Okay.
yeah, this is the idea.
Okay. Okay.
Hey Dhananjay, if you want to add anything you can add. Okay, I
Feel free to
So,
interrupt us.
Pavan, like, how do we know when we are getting into that zone of overfitting? So, um,
Yeah, that's a good
Uh,
question.
So that's what I think exactly will not know if I remember correctly. You will not know that okay, this is but yeah, there are ways actually.
Validations, right? Evals, Pavan. Evals will help us to figure out if we are going towards overfitting or we are going towards generalizing, right?
Because so far I was
Can I add
thinking that
little?
the more you train, the better it will perform, and
No, no,
yeah.
no, not like that. Yeah, Dhananjay, you were saying
Mm.
something.
I was saying like when you realize the model is overfitting, like this model is performing well when you are doing with the test data. Like see, first you are doing, you are as Binal explained, we are
Mm.
dividing data in the different like 80% you're testing, 10% you can do for the test, and then validations, three tests we are doing. So with the validation data, test data is performing well, but when the new data is seeing, it's not like not
Ah,
performing well. With the new data, the
correct,
validations is start dropping the
right,
Losses.
proper, like the data is
right.
so that times we apply some different techniques to stop, like regularization techniques, that is called a regularization technique we put. But how to
Mhm.
identify when the model is performing so well on the sample data, but when you are testing those model on the unseen data, like the validation set of the data you have, and then model is not performing well, so in that times you will realize the model is overfitting.
Overfitted,
So
correct,
we have
correct. Yes.
different technique, like this called regularization technique. So we use L2 regularizations, and if we need some, we add some, no, for underfittings we add the more data, like L2 regulation I can able to recall. So by that
Yeah,
way you can figure it out.
the early stopping is one actually.
Early
In
stopping, yeah,
Early
early
stopping is
stopping.
one, right?
That means
dropout
model is not
in
generalizing well.
Weight decay and dropout percentage, 10%, 20% we add to dumb down the neural network, that much percentage of neurons. Yeah. Laura?
no, no,
Uh,
that's okay. That's forget about it. Laura, let's not bring it here.
Early stopping, I am aware about. Data diversity. Yeah, that is also a point to figure out anyway. I mean, the more you train and the more you test it on the unseen data, you will know if the loss is increasing or decreasing. If the loss keeps on increasing with more training, it is overfitting.
Yeah, yeah, that's another point. Yes, correct.
So we do
If the
early
loss,
stopping in this case.
And what
yeah,
happens is you
Or we
use
perform assemble method also, drop out, assemble, that's operations we
ah
perform to.
yeah, gradient. No, no, okay. What is assemble, Dhananjay?
ensemble is if you can add multiple models
Multiple
together.
models, like models you use to see the output. So for different
Oh.
assembles, like two and three outputs you are evaluating together. One
But
model you can
that's
take the
for
chat GPT, Gemini, like these ones, and then you are analyzing the outputs.
No, are you
Dhananjay, ensemble valid for DNNs also, or it's only for traditional MLs?
No, 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 it's DNN. It's DNN. This is a regularization technique. So it's applicable for machine learning, deep learning in all these architectures.
Okay.
so when you
It's
say
applicable.
ensemble, that is the word if I've gotten it correctly. That means to use multiple base models and then see what gives the best results with your training data. Is it that?
Yeah, like the same data you pass to the, if you type this one in the Google, whoever sharing this thing, just see
Hmm.
one image. Like the same data you are passing to the different model, and then see how it's providing the
Okay.
output.
Ensemble, no? Okay, understood, man.
Mhm.
Okay. So the
Yeah, there are
whole
a lot of things: bagging, boosting, stacking. Yeah, a lot
So
of things
there
are
are
there.
in dropout also what happens is if I recall it correctly is the standard percentage that you use for dropout is 10%, but you can use 20% as well. That is also quite commonly used. Where 10% of the neurons of the deep neural network they are zoned out, they are zeroed out in the training, and that helps to improve upon generalization and kill overfitting.